I'd like to show you some solutions from a single source, all from Siemens. Today we'll be looking at these solutions revolving around manufacturing solutions for automotive, medical, and aerospace. We'll take a look at the automotive die being machined here at GROB. There's also a sample of the die here. So let's take a look at this from a solution source, all from Siemens. As we say, seeing is believing. So let's take a look. All of these solutions, we say, are all comprised from Siemens. We'll start with the CAD software on the end, which would be the ability to create and design the tool, the die, the fixtures, anything revolved around that needs to be held for the manufacturing of the part. Could all be done inside of Siemens NX product. Additionally, we can also take any other CAD data and use this in the product to send that on to the CAM software. In the CAM software, obviously, we create the tool paths and operations to produce the part. Part of this would also be a post-processor application to create a post-processor for the specific machine tool, whether that is lathe, mill, multi-axis, 5-axis, etc. In that case, you'll also be supporting, we'll say, the SimNumeric control line for the best of those features. We create that post-processor, sending it to the control, thus producing the part with the best optimum tool path in the SimNumeric format. If we take a look at the applications all inside of NX, we'll start over here with the box of these three items in CAD, CAM, and post-processing. All of those are contained inside the NX application, which was formerly Unigraphics. Then from there, of course, the same process would be to the control and then on to the machine tool. This includes machine simulation. In the CAM product, let's talk of functions inside of there. Turning applications, high-speed milling applications, 2.5 through 5 axis, as we've seen here on an impeller blade, along with a specific application for turbo machinery parts, blisk, hubs, wheels. Machine tool simulation is also comprised inside of the CAM application, so you can verify your tool path, positions, clearance moves, material removal before sending to the machine tool. CMM inspection also is an integral part of quality. It's all contained also inside of the CAM application for the inspection of parts. Feature-based machining. If you had CAD data from other competitors, say CATIA, ProE, SolidWorks, etc., all this data can be brought into NX CAM. We discover the features, select the features automatically with their tooling processes, and then output again to the machine with as little to no user interface. On machine probing, again, part of the quality initiative going on with CMM would be probing on the machine, again, inside of CAM. Interactive tool control, when we start moving into 5-axis applications, at times the positioning of the tool for the optimum clearance move can be difficult. So we have solved this by adding the interactive tool where you can grab the tool at any time in the tool path, change its orientation and its axis control, allowing for the best possible clearance moves or position or transition onto a surface. Parallel processing, if we look here, because sometimes tool paths can take a long time in calculation. As you see in the die, a finished tool path can be thousands and thousands of lines to be calculated. You can start that application, pick those surfaces, and go on and move on to other areas of the tooling process without interrupting any of the programming on the PC. That'll allow up to 4 other processes at one time operating. So you could move on to maybe do your email, you could do other CAM applications, other CAD applications, while this is all running and processing in the background. And then again, post-processing. We'll focus a little bit more about post-processing in the next slide. So the post-processing application rides inside the CAM application. So there's CAM, post-processing, which then moves to the control. And here we'll speak of the Siemens 840D control. In the post-processor application, you can select the options that the control on the machine is also selected for. So you can match them if you were using smoothing operations for the surface contours or spline output. All of those parameters could be matched to create the control, so when you're sending data from the CAM system, the tool path, they'll be output in the SimNumeric format. Thus a shorter format, allowing for more changes directly on the machine tool for the die. We'll take a little look about machine simulation. All of this again starts in the NX CAM application. The very first one is just a simple tool path verification. You can see the shaded tool and the workpiece with the cutting parameters that were decided upon. You take a look, if there's any changes, you see those graphically, move them, animate the tool, show material removal, shaded material removal if you wish, translucent material remover, etc. From there, you can move into basic simulation. If you're happy with the tool paths on there, you want to look at clearance moves, etc., the operations, how that gets to that on the machine tool, we can look at this in the basic simulation. Again, it would be looking at the tool path, simulating it on the machine tool to make sure you're happy with the process and the flow of the workpiece. From there, you can move to G-code simulation, so you could output this as G-codes for the machine. We actually plot and simulate the real G-code. So if a spindle speed operation, someone didn't turn the spindle on in the programming of the part, we will stop the simulation in NX CAM just as it would an alarm on the machine, or if we reach an over travel condition, we'll stop it there before sending to the machine tool. Can all be corrected, found, discovered, and fixed at that time. From there, we would move into the controller-specific machine simulation, where we actually use the same drives and software that is moving the machine tool. It's also the same calculations used in the simulation on the PC. So it is one data set doing the complete simulation to that. That would comprise, as we would say, a machine tool kit. So this would be an example of a machine tool kit. So you can see you would have all the motions, the animation of the tool. That could be displayed with material removal at the time, the tool path center lines, whatever. You could move in, zoom, pan, rotate, stop, pause. What comprises the machine support kit is really 4 components. There's a post-processor, which we had spoke about, which needs to format the data to the right machine. A simulation driver, which is the same driver that drives the actual motion for the machine. It's the same as the PC simulation. The 3D model, which comes from the tool vendor itself, right? So these would be the actual models, castings, assembly, and sheet metal that GROB uses are the same ones used in the environment. Lastly, CAM templates. What we do with CAM templates is, obviously the machine has standard tooling, fixtures, and devices that are used all the time. This is part of the template. So you would bring the machine tool onto the desktop to program the part, simulating the same environment of mounting the die or the workpiece onto the part, selecting the tools, setting the tools, and moving on. This would be the 4 components of a simulation kit. With that, I will have my colleague Ulrich come up and speak to you of the new functions and releases of the Simumeric control.